Okay, here we go. Finally now.
What are you investing in?
Random companies that I have no idea.
So let's just kind of continue on from what we did yesterday. Okay, refresh our memory a little bit about our integration formulas here that we should know. Okay, so we should be able to integrate a number, k. Okay, integrating k results in kx plus c. So for example, we saw for the homework yesterday, we had the integral of just plain old dx. But dx is really 1 dx, so the integral of 1 dx is 1x plus c, or just x. Okay? Integral of kf prime is then just kf of x plus c. So basically, if you integrate something with a coefficient, it's just like taking the coefficient kind of like out, integrating the thing, and then putting the coefficient back in. Integral of a sum or difference is equal to the sum or difference of the individual integrals there. Integral of a number, of x to a power, okay, this is like our basic kind of like power rule that we're going to see a lot of, right? The integral of something, x to a power, is x to the n plus 1, but then we have a 1 over n plus 1 out front. Okay, again, you got to think like a reverse derivative, right? If we were to take the derivative of this thing, the n plus 1 would come out front, divide by the n plus 1 here, cancel, and leave us just with x to the n, which is what that is right there. Okay? Integral of cosine is sine because the derivative of sine is cosine. The derivative of cosine is negative sine, so therefore the integral of negative sine is cosine. Okay, and so on and so forth with all the trig rules. Integral of e to the x is just as easy as it was as the derivative. And then the integral of 1 over x, which is the same thing as the integral of x to the negative 1. Okay, so this will catch some of you. I will tell you right now. You're going to see integral of x to the negative 1, you're going to think, okay, I just have to add 1 to my power, so it's going to be 0, and then I'm going to do 1 over 0 out front. I'm like, now it's undefined? And you're going to say undefined, and that's not the answer. It's natural log.
Exactly what it is. What do you do when the power equals 0?
Right, and there it is, okay? So it's natural log. But again, it's kind of interesting here that something that could, we can do the integral of x to the 1, that's this rule. Something completely different than the integral of x to the negative 1, which is this rule. Completely different, okay? So just because something starts out looking similar, when you integrate it, it could end up being vastly different than two things that look similar to each other could be vastly different when you integrate them, okay? So keep that in mind. All right. So there's levels of complexity in there that, we don't always get to see until, we actually do it and stuff, so. Anywho. Let's take a look. So letter C here, all right? Again, our task is to rewrite this, because as it's currently written, can we take the integral of this?
No.
Why not?
Because there's a product we don't know.
We have a product, and we don't know how to do a product, okay? So for letter C, what should we do to rewrite this then?
Distribute.
Yeah, distribute. I wouldn't, FOIL, I mean, I get what you're saying, this, yes, but we would, just distribute there. So just distribute all three of those terms there, so it's going to be the integral of 6t cubed minus 18t squared plus 2t, and then the dt. Okay? So again, I know it's like hard, just because we're getting used to this here, understand that the integral and the dt are kind of like grouping, okay? They group this entire thing inside the integral, so all three of these terms are being integrated here. All right? If I were to add like a 2 to the outside here, if I put like a plus 2 right here, I'll be like, if I put like a plus 2 right here, this plus 2 would not be integrated. It would just be this stuff right here that's indicated. This would be integrated, okay? And then you would add 2 to whatever that answer is, okay? Normally you don't see it there. You normally see like the 2 on the in the front. For
your response, do you recommend putting parentheses?
You can. I mean, if you want to put parentheses around it like that, if you want to put, this is not wrong. But you don't have to. It's understood that between the integral symbol and the dt, that's grouping together the integrand. All right, so anyway, now we go to integrate this. So the integral of 6t cubed, well, t cubed will become t to the 4th, and so we need to put a 1/4 out front, but there's already a 6 there, so it'll become 6/4. Okay? Integrating t squared becomes t cubed, and then again, since it's t cubed, we've got to put a 1/3 out front. There's already a minus 18, so we minus 18 over 3. Integrating t will be what? T squared. We're going to add 1 to the t to the 1, so it becomes t squared. And again, since there's already 2 out front, we're going to have to make it 2 over 2 plus that. And then still further yet, we have one more thing we have to do here, and what's that? Plus c. Yes, don't forget those plus.
Question.
Yes.
So when we're solving an integral, once we get past the integral sign, like when we get to the, I guess, the original function, what do we denote that as?
Like this?
Yeah.
So I see what you're saying.
Like, what do we call it?
Ordinarily, there's not, like, this is not defined as a function. Like, ordinarily, this is what you're given.
Yeah.
And so just putting an equal sign to this and then an equal sign to this, that's fine. You don't. There's no need to, like,
Just, like, equals
a
down
further
the line.
notation. Exactly.
Okay.
Yes, exactly right. Because, like, this and this are exactly equivalent. When we started with a function and then took that function's derivative, we were given f, maybe I had to simplify that, and then we did f prime to it.
Okay.
This thing already has kind of like the operation in it. It's got the operation symbol there, so you don't have to then make a different step.
Okay.
It's got it there.
So it's not like f of c or something like
Yeah,
that.
exactly right. You don't need to do that, No. All right, so we have a little bit of simplification here, don't we? What can we simplify here, Anna? What can we simplify in this? With the way I have it written here. So potentially, although c does not have a t attached to it. So I'm just talking about like the coefficients here, right? Like what, 6/4? What can we say there?
3/2.
Yeah, 3/2 t to the 4th. And then 18/3 becomes what? 6 t cubed. And then 2/2 becomes, yeah, so 1, I'm just going to put t squared, and then plus the c. And then that's really all we can do. You might think, yeah, okay, these all have t's, but the c does not have a t, so we don't want to factor a t out of that. Oh, sorry, it's off the screen. There it is. Okay? So that is the final answer. All right? And yes, folks, I do want us to get in the habit of rewriting, integrating, and then simplifying. Okay, at least for now. Later, you guys can worry about like skipping steps and stuff like that, but for right now, we need to do baby steps. Okay? All right, letter D.
We got foil.
Yes, this we need to multiply out, okay? We don't have a chain rule for integration. Remember, if we took the derivative of this thing, that's not a problem, but the integrating this thing, we don't have a chain rule for the integration. So we have to rewrite it as t squared plus 1 times t squared plus 1 dt, which is then really the integral, let's see here, t to the 4th plus 2t squared plus 1 dt. Okay. And so then this becomes
5 t to the 5th
1/5 t to the 5th.
plus
Okay. Plus 2/3 t cubed. Now, integral of 1 is what?
t.
T to the 1.
Yeah.
Right? You can think of 1 as being like 1 t to the 0. Okay, 1 is the same thing as like saying 1 t to the 0. And so when we integrate t to the 0, we add 1 to its exponents, it becomes t to the 1, and then divide by the new power 1, but it's 1 divided by 1, so it still is just 1. And then plus c. And is there any simplification we can do here?
Well, you could put
t to the
t in
5th
the
over 5.
numerator if you wanted to.
Yeah, so you could put it like t to the 5th over 5 if you wanted to, 2t cubed over 3 if you wanted to, and then just t. But I mean, really, this is it. There's not really much simplification you can do there. So that is kind of your final answer. There's no need to then simplify further, I would say there.
I hate it when t's are a variable, because my t's look like plus signs.
Put a little tail on.
I make them like I like curve like that. I remember most people do that.
Thank you.
I would try to go sooner rather than later, just because I don't know how long they're gonna be cooking and stuff like that. So.
Should you make the sausage one?
All right, so 1 to 20. Let's see here. So let's go with. All right, so Christian, how about this next one here? How we go about simplifying this? How could we rewrite this one?
Could you multiply by x to the negative 2?
Okay, so yeah, we could rewrite this. We can think of it instead as being integrating, instead of dividing by x squared, we could multiply by x to the negative 2 and distribute it. So x cubed plus 3 dx. Okay. Now, can we integrate it like this? Yes, still not yet. But now, yes, now we can distribute that. X to the negative 2 times x to the third, Christian, becomes what?
X.
X to the 1, or just x. And then x to the negative 2 times 3 becomes, well, 3. Yeah, x to the negative 2, and then don't forget the dx. The bar, or the little squiggly, the bar. How'd you draw the bar?
What's the point of like
I Googled it.
What's the point of that? It's to show that we want to integrate this thing, okay? But we have not integrated it yet. It's like an operation. It's just like plus. Like we have this symbol here to show that we want to add these two things. We have this symbol here to show that we want to add these two things together. We have not yet added them together, so that's like something to be done. Similarly here, this is to show that we want to integrate these things. We have not yet integrated these things, and so we still have this as a reminder that we're going to be integrating eventually. And that's what that's to show. It's an operation. All right, now we're going to integrate, though. Now we're able to. So, Christian, what's the integral of x?
1/2 x squared.
1/2 x squared, great. And the integral of 3x to the negative 2?
Negative 3x to the negative 1.
Very good. Yeah, don't forget here, folks, we're adding 1 to negative 2. Negative 2 plus 1 is negative 1. And then divide that new power by, divide the coefficient by that new power. So it's, negative 3. And then the plus c there.
Can you put that sign in front of everything?
Until you integrate, yes. And so notice here, I did not draw it because now we've integrated. The dx also goes away because we've integrated now. Okay? So very important here, folks. You do not drop the integral or the dx there until you've actually done the integration. This is all simplification. That was not calculus. Now we did some calculus.
Question. Where'd your x squared come from?
So,
Wait.
when we had, yeah.
I see exactly what I did.
Okay? And now the only little simplification we could do here is rewrite that 3x to the negative 1 as, I'm going to put it 3 over x like that, and then plus c. Or you can do 3 times 1 over x or whatever, but yeah, there it is.
If we don't simplify, would it be?
Is this? So no, this is fine, but understand that traditionally, like for multiple choice answers and stuff like that, you don't normally end with negative exponents. You would end up with wanting to translate to positive exponents. So. Okay, good. Thank you, Christian. All right. Any other questions on letter E? All right, then F. Emma. No. F is for fun, Emma. Come on. How should we rewrite this one? Yes, perfect. You guys hear that? I hope so.
Yeah.
Cube root of x is x to the 1/3. Okay, that's perfect. Exactly what we have to do here. All right, we got to distribute, right? Can't multiply, can't integrate just yet. So let's see here. What is x to the 1/3 times x, Emma? X to the 4/3. Very good. Minus x to the 1/3 times 4. 4x to the 1/3, and then the dx. Good. Oh boy, now we do fraction arithmetic. Yeah, okay, so equals. All right, so we're going to add 1 to our exponent here. So Emma, adding 1 is like adding how many thirds? 3. So what's our new exponent going to be? 7/3. See, how hard was that? And then it's going to be 1 over 7/3, which is really what? So I'll just write this out for right now. 1 over 7/3. Okay, minus. All right, and then it's going to be, we're going to add 1 to 1/3, but again, adding 1 is like adding 3/3, so our new power is x to the 4/3, and it's going to be 4 over 4/3, and then plus c. Okay. But what's the same thing as doing 1 divided by 7/3? What does that equal to? 3/7. It's a reciprocal, right? Dividing by a fraction is the same thing as multiplying by its reciprocal. So 1 divided by 7/3 is the same thing as doing 1 times 3/7. So we get 3/7 x to the 7/3. 4 divided by 4/3 is the same thing as doing 4 times 3/4. So 4 times 3/4. I'm going to write that one out because it's easy to see once you have it written out. What is 4 times 3/4? Yeah, 3. Yeah, so I'm going to have to write this one more step here. So it's minus 3 x to the 4/3 plus c. Okay. And of course, these 7/3, I could rewrite that as the 3/7 times the cube root of x to the 7th power, and this is minus 3 times the cube root of x to the 4th power. You should be able to convert back to the roots and stuff. If it's multiple choice, you gotta be able to match your multiple choice answer. Now, I'm not, again, Brandon, I'm not saying I'm gonna do that, you know, but I mean, you should be able to convert this to a root and stuff.
They weren't donations.
There weren't donations, $5.
I
Oh.
gave you a $5.
So you were like, no, thank you then?
Yeah, I was like, well, I only have $2, so never mind.
If you want, you can have some of mine.
It's good.
All right.
Oh, you have some left?
Some money left? Yeah.
Oh, I thought you meant like stamp money.
No, you can have some of my, you can have some money if you want if you want. You can give me back on Monday.
I'm gonna do that. I'm gonna do that. I'll just tell you this.
It's in my drawer. It's in my drawer there if you want.
Did they accept debit?
No, it's cash.
PayPal?
Can you go pee?
Western Union?
That's the sketchiest.
Grill? Western Union?
All right, so
Girls like their-
this next one. Okay, this next one. What can we do here? I'm gonna take it.
When you bring the cosine up, will it be cosine negative 2?
Yeah.
Or would it be, could you do cosine squared of x to the negative 1?
Yes. It'll be the same thing. But I don't think it's gonna help though. I think it's gonna help. All right. Any ideas here? Let me give you let me get you started because this one's kind of weird to see.
Yep, did
Okay.
not think of that.
Isn't this true?
Yeah.
Now, why is this helpful? What is sine over cosine?
It's tangent.
Tangent. What is 1 over cosine?
Cotangent. Or secant.
Secant. Hup, hip, hup, hey. All right. Yes. That's okay. I do that too, Ron. I should make fun of you. Tangent x, secant x. What's the integral of tangent x, secant x? Or secant x, tangent x?
Hold up, secant.
Wait a minute. That's right. Secant x plus c. Okay, that's legit. Okay, that's not obvious, right? But that is legitimate. We can do that.
I love math.
Maths.
What are you, English?
All right, last one here.
Oh, gosh.
Can we integrate secant squared?
Yes.
What's the integral of secant squared?
Tangent x.
Tangent. Can we integrate cosecant squared?
Yeah.
What's that?
Well, yeah, it would be negative cotangent.
It'll be negative cotangent, right? Because the integral of negative cosecant squared is positive cotangent. So then, yes, right, exactly right. And then, but 2 over theta. What do we have to do to that? Yeah. So let's rewrite this real quick here because it's secant.
No.
Secant squared theta plus 2 theta to the negative 1 plus cosecant squared theta d theta. All right, so now we have it rewritten, right? We can't do a integral of a fraction like this when we're doing the division. So we have to rewrite that as 2 theta to the negative 1. Integral of secant squared theta is what we just say it was, sorry? Tangent of theta. Integral of 2 theta to the negative 1.
Wait, shouldn't it be tangent theta plus c?
We're gonna combine all the c's together at the end. Integral of 2 theta to the negative 1.
Doesn't work. Doesn't work.
No.
But we can't do natural
Wait,
logarithm that way.
No. Hold up.
Would it be 2 ln?
2 natural log of the absolute value of theta.
Yeah.
Okay. Remember, this is like x to the negative 1. So integral of x to the negative 1, natural log absolute value of x. Integral of theta to the negative 1, 2 theta to the negative 1, 2 natural log absolute value of theta. Integral of cosecant squared, negative cotangent theta plus c. Yes.
Is it 3c or just c?
Nope, just c. Because even though you're right, so we could do a plus c with each one of these things, but we put 1c because all those c's we say just like absorb together
Oh, yeah.
to 1c.
Because it could be anything.
Right.
It,
Yes.
putting 3 would be like redundant.
Yes. All right. Now, using our natural log properties here, I just want to throw something else out at you just so you can see this. Using our natural log properties, what can we do with this 2? That's the coefficient here of natural log. That 2 can go inside as a what?
Exponent.
As an exponent. No, but I'm just saying you should be able to recognize that it can be done. Notice also, I drop the absolute values. Why can I drop the absolute values when I bring this in and square it? Because theta, when we square it, is going to be positive, so it doesn't matter whether we have the absolute. We don't need the absolute values in there anymore. Theta will be positive, so you can drop that too. If you have them in, it's not a problem, and it's not a problem. It's just redundant.
Cool.
There it is. Neato burrito, right?
Whoop, there it is.
Whoop, there it is.
I'd rather get a sausage sandwich, but,
Spicy meatball.
Tyler.
All right, so we're gonna move on here. I know we still have some time. All right, we want to stop, but we're not. We're gonna keep going here. Okay, I know it's Friday, but we're gonna keep going. All right, so we're gonna press on here.
Find the
$5 is actually kind of
Do what now, Emma?
particular.
but it's
I did. Yes, if you.
Can you bring me a sausage sandwich?
It might just be $4, but if you want like sausage, egg, and cheese, it's $5.
Okay. Well, I'll go the frugal route.
Okay, so we're gonna find particular solutions to antiderivatives.
Sounds evil.
So, in many applications of integration, you are given enough information to determine a particular solution.
I'm in the video.
Yes, you are. You're internet famous now. In many applications of integration, you are given enough information to determine a particular solution. And I'm going to underline that. Particular solution. In other words, we find the C value. To do this, we only need to know the value of y equals f of x for one value of x. So basically we need a point.
We need like a coordinate.
This information, this coordinate that we're given, is sometimes described as an initial condition. Okay, it's not always the initial, so that's why it's not always the initial condition. You know, it's not always like the starting time, you know, you're at this position or something like that. But oftentimes you're given, it's what's known as the initial condition. It's like the starting place. All right, so I'll write out a quick example here, and then we'll get to that. So the function y equals the integral of 3x squared minus 1 with respect to x has only one curve passing through the point 2, 4. Find the particular solution. Okay.
Find that particular
So we're going to have to integrate, and we're going to have to figure out what the c value is that makes it work.
No.
So what do I mean by has only one curve passing through the point 2, 4? Well, let's think about this. If I integrate, I end up with something plus c. So that means my solutions are an infinite number of curves that are basically going to be, the only difference between them will be like they're going to be shifted up or down from one another. Because that plus c, right, doesn't that make it shift up or down?
Yeah.
Right, depending. So that's the idea. We have an infinite number of curves. When we talk about that general solution, because it's plus c, it could be all sorts of different heights. Okay? But for this one, we're going to have one specific curve that we're going to find the one curve that happens to pass through the point 2, 4. So, what should we do to start out here? Integrate. Yes. So, we'll take this integral. So, y is equal to the integral of 3x squared, yes, bless you, minus 1 dx. Sorry, my brain was computing there. And so, we're still equal to y, because we're going to integrate this now. Do we need to rewrite this at all? No. So the integral of 3x squared is going to become, so integral of x squared is x to the third or cubed, and then the new power we bring out front is 1/3. There's already a 3 there, so it's 3/3 x cubed, minus integral of 1 is x, and then don't forget the plus c. Okay? This, right, is the general solution. This indicates this is an infinite number of possible curves that solve this. But again, the only difference between all those curves is that there will be different heights. They'll be shifted up or down from one another. Okay, the plus c there. But now we're going to plug in, okay, our given condition, our point. Plug in our, I don't know, I guess I want to call it. I'm going to call it, it's not an initial condition because it doesn't start at 0. It's 2, 4. So we're going to plug in our point. All right, so where should the 4 go? And for y. So it's going to be 4 equals, and where does the 2 go? And for x. So it's 2/3, 2 to the third, minus 2.
Wait, 2/3?
3/3, can't read my own handwriting. Thank you. Now 3/3, is just 1, so that kind of cancels. I should have just dropped it in the first place. But 2/3 is 8. 8 minus 2 is 6. And so c is negative 2. This is not our final answer. What should our final answer be? Yeah, Ryan?
Y equals x to the third minus x minus 2.
Yes. Y equals x to the third minus x minus 2. This is our final solution. Because what was the question that was asked? Find the particular solution. It did not say find the value of c for this curve. It says find the particular solution. This is our particular solution. This is the particular curve that goes through the point 2, 4, and that is also the integral of 3x squared minus 1. When you take, and again, to check it, it's real easy. Just take the derivative in your mind. 3x squared minus 1. There it is, okay?
So to find the particular solution, you take the general solution and plug in your value of c.
Exactly right. Plug in your value, solve for c, and then rewrite, plug the c in. Yep, that's it. Very similar, right? Kind of similar in scope to almost like writing the equation of a tangent line or ish, we're basically, it's very similar to stuff we did with derivatives, There were times when we took a derivative and plugged something in to get a value. Well, now we're taking an integral, plugging something in to get something. It's very similar, in scope to what we've done before. All right. So actually, I'm going to have you guys try one here. So find the general solution of f prime of x equals e to the x, and find the particular solution that satisfies the initial condition, and this one we will call an initial condition. Inish condition. F of 0
Never gonna unpick that.
equals 3. All right. Find the general solution. And that's an initial condition because it's at 0, times 0, or in this case, x is 0, but that's why we kind of call it an initial condition. Our independent variable is 0, so that's kind of what it makes it a kind of an initial condition. It's a starting point. Actually, the integral of e to the x is very easy. One of the easiest ones we have to do. Oh, I got you. Remember, e is just a number. You look like you're about to burst.
So now we denote the second equation as lowercase f, right?
I finished my problem, I promise.
Decide no.
I think the bathrooms in the cafeteria might be crowded. You probably should go in the senior cafeteria to those bathrooms.
I will. Thanks for the intel, Mr. Wade.
Let me hide my dollar.
Anyway. Yeah. Too late. All right, Mac, what's the integral of e to the x? It's e to the x.
Oh, I thought that was
E to the x
times 1 plus c.
plus c. Times 1 is true, yeah, but plus c. So that means f of x, our general solution here, is e to the x plus c. All right, but we have a point, so we want to find the initial. We want to find the particular solution using that initial condition. So how do we do that, Mac? Now what?
You put 3 in for s. No, you put 0 in for s.
Right, so it's going to be e to the 0 plus c, and it equals what?
You can't do 1, 3.
3. Which one is it, 1 or 3?
3.
3. Yes, and what?
E to the 1 that you do? Or e to the 0?
What is e to the 0? What's anything to the 0 power except for 0 to the 0? It's 1. Yeah, so it's just 3 equals 1. So c is 2. So our particular solution at that initial condition is e to the x plus 2. And there's our general solution. Where did the 0 come from? The original, the point right here.
So the, like, basic.
Right, because this is f prime of x equals e to the x. That is not a point for f prime. This is a point for the original function f. How do you get the original function? If you have its derivative, you integrate. You integrate the derivative to get the original function. Well, you have the plus c there. Plug in the point to get the particular solution. C is 2, and so that's it.
So that was f of 1 equals 3, and
E to the 1 plus 2. Yes, equals 3. Yes. Yeah.
What was your video for?
You won't be able to use a point on f prime to find a point on f. So yeah. All right. Other questions?
S of 0 equals 3, the same as writing like 0 3.
Yeah. Yep. This is an alternative way to write it. But yes, it's equivalent.
He didn't put ours in.
All right. I'm going to give you guys your assignment. I think we're going to stop there. I have 2 more I want to go over, but I think I want to stop there.